So in today's video, we're going to take a detailed look at Radix Sort, one of the interesting sorting algorithms used in data structures and algorithms. Now, when we hear the word sorting, most of us immediately think about algorithms such as bubble sort, selection sort, insertion sort, or maybe quick sort. But Radix Sort takes a different approach. Instead of looking at two complete numbers and asking which one is bigger or smaller, Radix Sort looks at the individual digits of the numbers and processes them according to their positions. For example, if I give you the numbers 170, 45, 75 and 802, a normal comparison-based sorting algorithm might compare the values with one another to determine their order. Radix Sort doesn't need to work that way. It can look at the ones digit, then tens digit, and the hundreds digit and use those digits to organize the numbers. In this video, we are going to start from the basics, understand exactly what Radix Sort means, learn how it handles digits and characters, and then we'll look through a complete example step by step. By the end, you have a clear idea of not only how Radix Sort works, but also why it's called a non-comparison based sorting algorithm. Alright, so before we get into Radix Sort itself, let's quickly understand the problem that we're trying to solve, sorting. Sorting simply means arranging data in a particular order. The most common type is ascending order, where we arrange values from the smallest to largest. For example, imagine we have 8, 3, 6, 1 and 5. At the moment, these numbers are arranged in any particular order. If we sort them in ascending order, we get 1, 3, 5, 6 and 8. We can also do the opposite and arrange them in descending order, 8, 6, 5, 3 and 1. So, why is sorting important? Sorting is used everywhere in computing. Imagine a database containing hundreds or even millions of records. If the data is properly organized, searching and processing that information can become much easier. Sorting can be useful when organizing names, numbers, product IDs, student records, transaction informations, and many other types of data. Because sorting is such a common problem, computer scientists have developed many different sorting algorithms. Some algorithms compare elements directly. Others, like Radix Sort, use a complete different strategy, and that's what makes Radix Sort interesting. So let's define Radix Sort properly. Radix Sort is a non-comparison based sorting algorithm that sorts data by processing individual digits or characters according to their positions. That's quite a technical definition, so let's break it down. First, we have the word sorting. The goal is still to arrange our data in order. Then we have Radix. Radix relates to the base of the number system we are using. And finally, we have the important idea of processing individual digits. Let's say we have the number 527. Instead of treating 527 as one complete value, Radix Sort can look at the 7, then 2, and then 5. Each digit has different position and therefore a different significance. The purpose of Radix Sort is to use this position to organize the elements efficiently. Another really important point is that Radix Sort doesn't directly compare complete elements in the way that comparison-based algorithms do. Instead, elements are distributed into groups or buckets according to the digit currently being processed. So if you remember just one thing from this slide, remember this. Radix Sort organizes data digits by digits instead of comparing complete values directly. Alright, now let's understand what the word radix actually means. Radix basically refers to the base of the number systems. The number systems that we normally use in everyday life is called the decimal number system. Decimal has a radix of 10 because it uses 10 different digits, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. That's why in our example we are going to use 10 buckets. Those buckets are numbered 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. If you are using binary data, the radix would be 2 because binary only has 0 and 1. But for this video, we'll stay with decimal numbers. Now let's connect this idea to digit positions. Take the number 802. Starting from the right, we have 2 in the ones position. 0 in the tens position, and 8 in the hundreds position. These positions are extremely important because Radix Sort processes these positions one at a time. So when you see the buckets numbered 0 through 9 on your slides, remember that each bucket represents a possible digit in our decimal number system. Alright, now let's look at one of the most important ideas in Radix Sort, sorting by position. A number isn't just one value made up of random digits. Each digit has specific position. For example, take the number 472. The 2 represents ones position, 7 represents tens position, and 4 represents hundreds position. Radix Sort can use these positions one at a time. In the version we are studying, we start with the least significant digit, or LSD. The least significant digit is normally the digit on the far right. So, for 472, the LSD is 2. Then we move to the tenth digit, 7. And finally, we reach the hundredth digit, 4, which is the most significant digit, or MSD. So the direction is LSD to MSD, which means right to left. Let's look at another example, 170. The rightmost digit is 0, so that is our right digit. Then we move to 7. Then finally, we process 1. One thing that's important here is that Radix Sort doesn't completely rearrange the numbers randomly at every step. The ordering established during one pass is carried forward into the next pass. This is particularly important when 2 or more numbers have the same digit in the position we are currently processing. That's why the order of elements need to be maintained carefully during each pass. We'll see exactly why this matters when we get to our example. So far, we've been talking about numbers, but Radix Sort can also be used with characters and strings. Think about the list of words cat, bat, mat, and rat. We can process these words one character position at a time. If we are using the LSD approach, we start from the last character. In this particular example, every word ends with T. So after looking at the last character, there isn't really anything to rearrange. Next, we look at the middle character. Every word has A in middle, so again the order doesn't change. Finally, we look at the first character. Now we have B, Z, M, and R. These characters give us the order bat, cat, mat, rat. This example shows that the basic idea of Radix Sort isn't limited to the decimal numbers. We can apply the concept to strings as long as we have the suitable way to determine the order of the characters. So when we say Radix Sort process digits or characters by position, this is what we are talking about. Alright, here's our dataset. We're going to sort 170, 45, 75, 90, 802, 25, 2, and 66. Take a moment to look at these numbers. They are currently in no particular order. Our goal is to arrange them from smallest to largest using Radix Sort. Before we start putting anything into buckets, first we need to figure out how many passes we are going to need. To do that, we look at the number with the greatest number of digits. In our dataset, that number is 802. It has 3 digits. Therefore, we'll need to process 3-digit positions, ones, tens, and hundreds. That gives us 3 passes. Pass 1, ones digit. Pass 2, 10 digit. Pass 3, hundreds digit. Notice that the number 2 only has 1 digit. For the purpose of processing the tens and hundreds positions, we can think of it as 002. Similarly, 24 can be thought of as 024. This allows every numbers to be considered across the same tree position. So let's start with pass 1. For our first pass, we are looking at ones digit. This is our least significant digit. Let's go through every number carefully. First, we have 170. The last digit is 0. So 170 goes into bucket 0. Next, 45. The last digit is 5. So 45 goes into bucket 5. Next, 75. So it also ends in 5, so 75 also goes into bucket 5. Next, 90. the last digit is 0. So 90 goes into bucket 0. Next, 802. The last digit is 2. So 802 goes into bucket 2. Next, 24. The last digit is 4. So 24 goes into bucket 4. Then 2. Its only digit is 2. So its ones digit is also 2. Therefore, 2 goes into bucket 2. So finally, 66. The last digit is 6. So 66 goes into bucket 6. Now let's look at our buckets. Bucket 0 contains 170 and 90. Bucket 2 contains 802 and 2. Bucket 4 contains 25. Bucket 5 contains 45 and 75. And bucket 6 contains 66. All other buckets are empty. Now here the important part. We collect the buckets in order from 0 to 9. So first we take bucket 0. 170 and 90. Then bucket 1 is empty. Bucket 2 gives us 802 and 2. Bucket 3 is empty. Bucket 4 gives 24. Bucket 5 gives 25 and 75. Bucket 6 gives 66. So after pass 1, our order is 170, 90, 802, 2, 25, 45, 75 and 66. It might look strange because the numbers aren't fully sorted yet, and that's completely normal. We've only considered the ones digit. Now let's move one position to the left. Now we are ready for pass 2. This time we are going to look at the tens digit, and very importantly, we start with the order produced by pass 1. 170, 90, 802, 2, 24, 45, 75 and 66. Let's process them one at a time. 170 has a tens digit of 7, so it goes into bucket 7. 90 has a tens digit of 9, so it goes into bucket 9. 802 has a tens digit of 0, so it goes into bucket 0. Now we have number 2. We are treating 2 as 002, therefore its tens digit is 0. So 2 goes into bucket 0 as well. Next 24, its tens digit is 2, so it goes into bucket 2. So 25 has a tens digit of 4, so it goes into bucket 4. 75 has a tens digit of 7, so it goes into bucket 7. And finally 66 has a tens digit of 6, so it goes into bucket 6. So now let's look at the buckets. Bucket 0, 802 and 2. Bucket 2, 24. Bucket 4, 45. Bucket 6, 66. Bucket 7, 170 and 75. Bucket 9, 90. Now we collect everything from bucket 0 to bucket 9. We get 802, 2, 24, 45, 66, 170, 75 and 90. Again, this is not completely sorted yet. But notice that these numbers are becoming more organized according to their digit position. There's only one position left, the hundredths digit. So let's perform our final pass. So this is the final pass. We are now processing the hundredths digit, which is one of the most significant digits in this example. Our current list is 802, 224, 45, 66, 170, 75 and 90. To make this easier, let's imagine the smaller numbers with leading zeros. So 2 becomes 002, 25 becomes 024, 45 becomes 040, 66 becomes 0666, 90 becomes 090, and 170 stays 170, 102 stays 102. Now let's look at the hundredths digit. 802 has 8, 2 has 0, 24 has 0, 45 has 0, 66 0, 170 1, 90 0. So bucket 0 contains 2, 24, 45, 66 and 90. Bucket 1 contains 170. Bucket 8 contains 802. Now we collect the buckets in order. First come bucket 0, 2, 25, 45, 66, 90, and then bucket 1, 170, and finally the bucket 8, 802. So our final sorted list is 2, 25, 45, 66, 90, 170, and 802. And there we have it. Starting with a completely unsorted list, we use 3 passes: 1, tens and hundreds. We never had to directly compare the complete numbers with one another. Instead, we distributed them according to their digits. That's the core idea behind Radix Sort. Now let's focus on something our definition mentioned earlier, non-comparison based sorting. What does that actually mean? Let's think about a comparison based algorithm. Imagine an algorithm looking at two values and asking, is 45 smaller than 75? That's a direct comparison. Based on the answer, the algorithm can decide how to rearrange the elements. Algorithms such as bubble sort and selection sort work using these kind of comparison. Radix Sort takes a different approach. When we process in one's digit, it doesn't need to ask, is 45 smaller than 75? Instead, it looks their current digits. 45 has a ones digit of 5. 75 also has ones digit of 5. So both are placed into bucket 5. The algorithm is using digit positions and bucket distribution instead of directly comparing the complete values. That's why we clarify Radix Sort as a non-comparison based sorting algorithm. This difference is one of the main things that makes Radix Sort unique. So now that we understand how Radix Sort works, let's look at some of its advantages. The first major advantage is efficiency for suitable large datasets. When we're dealing with numbers that have a limit numbers of digits, Radix Sort can be very efficient. Its commonly discussed time complexity is O of t times n plus k. Here, d represents the number of digit positions we are processing. N represents the number of elements and k represents the number of possible values for digit. In our decimal example, k is related to the 10 possible digits from 0 to 9. Another advantage is stability. A stable sorting process preserves the relative order of elements that have the same sorting key. This can be used when sorting structures or multi-level data. Examples can include integer values, identification numbers, fixed length strings, and other data where processing individual digits or characters makes sense. When the conditions are suitable, Radix Sort can be very effective sorting technique. Alright, so let's bring everything together. We started by looking at what sorting means, arranging data into a particular order. Then we introduced Radix Sort as non-comparison based sorting algorithm. Instead of comparing complete elements directly, Radix Sort processes individual digits or characters according to their positions. In our example, we used LSD approach, which means we started from the least significant digit and moved toward to the most significant digit. We processed 3 positions, ones, tens, and hundreds. During each pass, the numbers we placed in buckets from 0 to 9 based on their current digit. Then we collect the bucket in order and use that result for the next pass. We started with 170, 45, 75, 90, 802, 25, 2, and 66. After pass 1, we sorted according to the ones digit. After pass 2, we processed the tens digit. And after pass 3, we processed the hundreds digit. Our final result was 2, 25, 45, 66, 75, 90, 170, and 802. So if you want to remember Radix Sort in the simplest possible way, remember this. Don't compare the whole numbers. Look at the digits, place them into buckets, collect them, and move to the next position. That's the basic idea behind Radix Sort. And that's bring us to the end of this video. Thank you for watching, and I hope this explanation made Radix Sort much easier to understand. I'll see you in the next video. Peace.